how to identify. Okay. So for example, if I give you randomly a salt and I tell you it's sodium sulfate, okay, how can you prove to me it's actually sodium sulfate? Now, how many types of salts are there? How many types of salts? Agak-agak, how many types of salts are there?
One.
One?
Huh?
Wait, think carefully.
What? I
How
cannot.
many different types of salts?
In
How many different types of salts are there that I have taught you that you know how to prepare?
hmm, let me check my notes. 7.
No. Okay, like this. Remember, I taught you potassium, sodium, calcium, magnesium, aluminium, zinc, iron 2, iron 3. Do you remember?
Yeah.
Copper 2. Then I taught you silver, barium. Then there is nitrate, sulfate, chloride, bromide, iodide, and carbonate. Okay? If silver combined with carbonate, it's silver carbonate. If silver combined with nitrate, it's silver nitrate. Silver sulfate, silver chloride, silver bromide, silver iodide. Aluminium carbonate, aluminium nitrate, aluminium sulfate, aluminium chloride, aluminium bromide, aluminium iodide. Okay, now tell me how many kinds of salts are there? Zihua, you understand my question or not?
Yes. How many type of salt?
So can you answer now? Give me a
6.
rough. Yeah, more than 50, 60 plus, almost close to 80 actually.
Oh.
Okay? Because you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, multiply 1, 2, 3, 4, 5, 6. Okay? Plus some more there's others that I haven't put here yet. So there are many, many, many different kind of salt. So how do they ask you in the exam is they will give you a random salt and they will ask you to test what is the salt. Okay? They will ask you to test what is the salt to prove to me that it's sodium sulfate. Or they will give you something random like that, salt X, and then they say they did this, they did this, they did this, they did this. Tell me what salt is it. Okay, so if you have 80 over possible suspicious suspects, how to do like that? Isn't it very difficult?
Yeah.
So when we are given a salt, we know that the salt has a positive ion and a negative ion. What we do is we do a series of tests to find out who is the negative. Then we do a series of tests to find out who is the positive. Get it?
Okay.
Okay. So I want you to very quickly look through these. These are the anion tests. Okay, these are the anion tests. Carbonate, chloride, bromide, iodide, nitrate, sulfate, sulfide. Okay, have a quick look through and I'm going to explain to you how to do it. Okay, ready? Ready, yeah? Okay. So remember, I'm going to teach you about carbonate, chloride, bromide, iodide, nitrate, sulfate, sulfide. Okay, let's say I have a salt. I don't know what it is. Okay, if I add that salt with acid, and immediately the gas that comes out is carbon dioxide. How do I know it's carbon dioxide? How do I know something is carbon dioxide? Zihua, how do I know something is carbon dioxide?
Lime water,
Okay, what happens to the lime water?
you become cloudy and chalky like that.
Very
Milky.
good. Okay, so that's how I know it's carbon dioxide. If I add acid and it releases carbon dioxide, 100% this salt contain what anion? Hua, do you know what's my question or not?
This is, huh?
Can you hear me or not?
Yes, but quite soft.
I'm very soft. Is that what you're saying?
Yeah.
Everything is the same.
Let me check my volume problem.
Yeah, can you check your volume, please? Because I can hear you perfectly and everything is the same setting. And
Oh,
I check
I go
my,
full, yeah.
sorry, what?
I go full volume now.
You increased the volume already.
Yeah.
Now, okay?
Now, okay.
All right. So now my question to you is, if I add acid and it releases carbon dioxide, 100% I know what is the anion inside here.
And ion. And carbonate.
Yes, because carbonate plus acid releases carbon dioxide.
Carbon dioxide.
Can you understand?
Yes.
Okay, so as long as it releases carbon dioxide, when I add acid, 100% this was a carbonate. So that's how I do my first test for carbonate. So carbonate is the easiest. Carbonate basically releases carbon dioxide. Can you understand?
Mm-hmm.
Okay. Second one. Now, do you remember solubility? Do you remember solubility?
Yep.
Okay. Can you tell me chloride, bromide, iodide, who is insoluble?
Let me.
Look at your list. Chloride, bromide, iodide, who is insoluble?
Iodide.
No. Chloride, bromide, iodide. What chloride, what bromide, what iodide is insoluble?
Chloride is silver chloride and lead chloride.
Is it the same for bromide and iodide? Is
Yes.
it the, yes, okay. So what about sulfate? Who is
Sulfate
in,
is barium sulfate, calcium sulfate, lead sulfate.
so barium, calcium, lead. This one is, okay. When I want to differentiate between a cat and a dog. Does it make sense if I ask you to see which one has a tail? Does it make sense?
No.
Because both also have a tail, correct or not?
Yeah.
Okay, so it won't make sense. So instead of asking you who has a tail, I should ask you which one has sharp claws and which one doesn't have sharp claws, right? So
Yeah.
when I want to differentiate something, I don't use something that is the same. I use
Use
something
something
that,
different.
yes. So lead cannot. Okay. So
Mm-hmm.
for chloride, bromide, iodide, you remember the best friend is silver. Okay. For sulfate, the best friend is barium. Why don't
Okay.
we use calcium? Because calcium sulfate is partially soluble. Okay.
Oh, it's partially soluble.
Yeah.
Okay.
So we don't really use it. Okay. So now, if I have a solution, I don't know what's inside. Okay.
Okay.
What I do is I add silver nitrate solution. Okay. Now, if there is silver nitrate solution, in the silver nitrate, the silver and nitrate is soluble or insoluble?
Silver nitrate.
Soluble or insoluble?
Soluble.
Sorry?
Insoluble.
Can you please look at your list? Silver nitrate. Look at your list properly.
All nitrates are soluble.
Yeah, so soluble or insoluble?
Soluble.
Okay. So now, because it is soluble, they will stick together or they will separate in water.
Stick.
You soluble means what? So,
Dissolve in
you
water.
sorry,
Can dissolve in water.
can dissolve in water, so it won't stick together. Okay, it won't stick together. So it will separate and it will move around in the aqueous. That is what soluble means. I add it together to this unknown substance. Let's say I know the substance is sodium something. I don't know what lah. Okay. Now let's say it's sodium chloride. Okay. The moment I add the silver nitrate into sodium chloride, who is going to stick to who? Who loves who in this scenario? Who is the one that sticks together? I've taught you this before in precipitation reaction. Can you think a little bit? Think a little bit. Precipitation reaction. Go back and see precipitation reaction.
Sodium chloride.
Who is insoluble here? Insoluble means they will go and stick together and find each other. In this form, who will stick together? Only the insoluble will stick with the insoluble.
Yeah.
Does silver love nitrate? No. Does silver love sodium? No. Does sodium love nitrate? No. Does sodium love chloride? No. Does silver love chloride?
Yes.
So what will happen when they see each other? Immediately they will stick together and
Uh-huh.
form a what?
Precipitate.
Precipitate. The precipitate will be silver chloride. What is it that you will be able to see? You cannot say I see silver chloride. You see white
White
precipitate.
powder. Oh, precipitate.
So if I see white precipitate, that means it is chloride. If I don't see white precipitate, that means it is not chloride. Is that correct?
Yep.
Okay. Now, what what if I tell you How do you know it's not silver carbonate? Could it also be a carbonate? Why not?
Hmm. Ag2CO3.
Hmm?
Ag2CO3 is insoluble.
Ag2CO3 is insoluble. Yeah, so how do I know it's not Ag2CO3?
Color different. Color is different one.
I must do something where I get rid of the CO3 so that if there is any precipitation, it is 100% chloride. Do you think I can get rid of CO3? How do you think I can get rid of CO3?
Put a more reactive metal inside.
Showing you the answer already, you think a little bit.
Add acid.
Add acid. If I add acid, if there is a CO3, what will happen to the CO3?
It will become carbon dioxide.
And it will dissolve. So that's why before I add nitric acid, before I add sodium nitrate, silver nitrate, I must add nitric acid first. This is to remove any carbonate. And then number two, I add silver nitrate. So if it is a white precipitate, it is a chloride. If it's not a white precipitate, it is not a chloride, which is what this entire set that I just gave you means. See? Add dilute acid and then test for carbon dioxide. Effervescence carbon dioxide produced means it's carbonate. Acidified with dilute nitric acid, then add aqueous silver nitrate. If it's a chloride, I will see a white precipitate. If it's not a chloride, I won't see a white precipitate. That's it.
Yep.
Do you understand now? Okay.
Yes.
So now, if it is it is sodium bromide, I do the same thing. I add nitric acid, then I add silver nitrate. Who and who are insoluble?
Insoluble.
Hmm?
Silver bromide.
Okay, so what will happen?
Form a precipitate.
What's the color? So if you see cream precipitate of silver bromide, then you know it's a bromide. Okay? If it's
Okay.
iodide, so here you see the three colors. If it's white, it's chloride. If it's cream, it's bromide. If it's yellow, it is iodide. Because silver chloride is white, silver bromide is yellow, and silver bromide is cream, and silver iodide is yellow. Can you understand? Can you understand the concept now?
Yes.
Okay. Okay, so carbonate, add carbon dioxide. Chloride, bromide, iodide, add nitric acid, and then silver nitrate. Okay. Now we do sulfate. Just now I told you what sulfate is insoluble. What sulfate is insoluble? You just told me.
Barium sulfate. Calcium
Okay,
sulfate.
okay, which one do I use? Calcium cannot because it is slightly soluble. So which one do I use?
Lead sulfate.
Sorry?
Barium sulfate.
Yes, barium. So using the same concept, Using the same concept, what are the, as just now that reaction, what are the two chemicals that I add so that I can see a white precipitate of barium sulfate? Then I know it's sulfate. What are the two chemicals that I add to make a precipitate?
Sulfuric acid.
No, I cannot add sulfuric acid when I want to test a sulfate. I still use nitric acid.
Oh, okay.
Okay, what else?
Nitric acid and barium chloride,
Hmm?
barium carbonate.
Barium nitrate. So I add nitric acid and barium nitrate. So who will go and find each other? Barium will go and
Barium
find
sulfate.
sulfate. And what will you see? A white precipitate of?
Barium sulfate.
Okay. Do you understand or not now?
Yes.
Okay. So that's why you see this reaction here. Acidified with nitric acid, then add. Okay. So therefore, this one is okay. So this one Gautim, this one Gautim, 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 Gautim. Okay. So the two problematic ones are nitrate and sulfide. Why is nitrate? Why is nitrate problematic? Why do you
Why
think so?
is, why is nitrate what?
Problematic. Cannot use the same method. Why?
Because we are adding nitric acid.
Okay, another reason?
Nitrogen. Wait.
Think a bit, think a bit. Use your common sense, think a bit. Think a little bit. Why nitrate? What is so special about nitrate? All nitrates are what?
Soluble.
So, if all nitrates are soluble, will I ever get a precipitation?
No.
So what should I do? So I cannot use precipitation method. Okay? So therefore, nitrate we use a special method. Alright,
Hydration?
okay. No, no, no. Okay. Can you see the word here, ammonia is produced?
Yup.
Okay, so I'm gonna focus on nitrate, okay?
Okay.
Now this is special. The test for a nitrate salt and the test later on that you will learn for an ammonium salt is almost the same. That means I want to prove that there is ammonium ion and I want to prove that there is nitrate ion. The method is almost the same. Okay?
Okay.
All right. So the both reactions, I add sodium hydroxide solution and both reactions I heat. Both also I need to heat. The difference is to test for a nitrate, on top of adding sodium hydroxide, I put a piece of aluminium foil. Okay? Understand so far?
Yes.
Okay, now what will happen is both of them will release ammonia gas. If I do this experiment with sodium hydroxide only and it releases ammonia gas, I know 100% is ammonia. If I do this experiment with sodium hydroxide but I add aluminium foil and it releases ammonia gas, I know 100% is a nitrate. Okay, got it? How do I test for ammonia gas? Look at the list I gave you just now, the one that I sent to you on WhatsApp.
Let me check my WhatsApp.
Then find or not how you test for ammonia gas. The list that I just gave you got 2 pages, my dear. It's only 2 pages. You look at the list properly. Here, this one, this page. Can you see here? This page.
Turns them litmus paper blue.
Turns them red litmus paper blue. Yes. So that's how you know it's ammonia. Okay. Do you understand this concept here?
Yes.
Okay. So now we know how to test for ammonium. We know how to we know how to test for ammonium ion, nitrate ion, bromide ion, chloride ion, carbonic ion, sulfate ion. Now let's the last one only, sulfide ion. Okay, sulfide ion is the only one that is different. Okay, a small volume of, do you remember this chemical? Acidified potassium manganate 7. Do you remember this? Do you remember what's acid?
Potassium
Ah,
manganate 7.
yeah, it will change from purple to colorless.
Purple to colorless.
Okay, so it is to test this same experiment is to test for sulfide, is also to test for sulfur dioxide gas. If you look at your list, you will see it's also to test for sulfur dioxide gas. Can you see?
Yes.
Ready? So this is all how to test for anions only. Now we're going to look at cation ions. So if you look at your list, the cation ion list very, very long. Can give you a headache, right?
Yes.
Ah, you don't have to memorize for paper 6, but for paper 4, you must memorize, unfortunately. Okay? You must memorize for paper 4. So that means in the end also must memorize lah. Okay. You don't have to test all the cation ions. You look at the ones you need to test. Aluminium, calcium, chromium, copper, iron 2, iron 3, zinc. Can you see those? Okay. Now, which is the one we already tested? Look at my share screen. Which is the one we already tested?
Aluminium.
No. We used aluminium just now. We did not test aluminium.
Oh, ammonium.
Yes. Okay, we already test ammonium. Okay, so now we left the rest. Okay, I'm gonna separate them into two groups, and then I want you to tell me what's the difference between the two groups. Okay, are you ready? There's a group in yellow and there's a group in blue. In not yellow. Okay. Okay. What do the ones in yellow have in common?
Aluminium, ammonium, calcium, zinc.
What do they have in common?
White precipitate.
Yes, they are all white. Because are they transition metal? Are they transition metal? Look carefully and see.
Transition metal. Chromium and iron.
No, no, no. The ones that are white, are they transition metals?
No.
Okay, so that's why they give different, they do not give colored compounds because they're not transition metals. The ones that give colored ones are only chromium, copper, iron 2, iron 3. Get it? Now, this one is very easy. Basically, we only have two reagents that we need to add. One experiment, we add sodium hydroxide. Another experiment, we add aqueous ammonia. Okay?
Mm-hmm.
Okay, so this is how you do it. You take an unknown, you take an unknown, you add a few drops of sodium hydroxide. You read here, can you see the word excess? What does it mean? So it means that first you add a few drops. If you see a white precipitate, then there's two things you can do. You can add a few more drops. You add more sodium hydroxide. When you're adding more sodium hydroxide, it is actually, okay, when you're adding more sodium hydroxide, it is actually adding in excess. Okay?
Yes.
All right. So when you add in excess, two things might happen. Either the precipitate dissolve or the precipitate doesn't dissolve. Get it?
Okay.
Okay. So in this case, if the precipitate dissolve, it's aluminium or zinc. So you notice, you look at this carefully, more sodium hydroxide and then suddenly the white precipitate dissolve. It disappears. It's either an aluminium ion or zinc ion. Okay? You read carefully. You see the one for aluminium and the one for zinc. Is it the same results? Can see it.
Yeah.
Is it the same results?
Mm, yes.
Okay. So if it's the same results, how do I know it's aluminium or it is zinc? So this is test one. I do test two lah. So if I add aqueous ammonia instead to a fresh test tube, that means a new test tube, can you tell me whether the results are the same? No. For aluminium, it will have a white precipitate insoluble in excess. But for zinc, it's a white precipitate. It is still soluble in excess. Can you understand?
Yes.
Hmm. So this one you have to slowly remember lah. But you can look at your list now. For now, you can look at the list. Okay? I'll give you a few moments to absorb. Okay. Have we learned about ammonium already?
Yes.
Okay, so now calcium. Calcium will only have a precipitate with sodium hydroxide. With ammonia, no precipitate. Easy?
No.
For now, you just have to remember. For now, you can, uh, n- now you can uh, refer lah, so it doesn't matter. Okay? All right. So now left with the one with colors. If it's blue, it's always copper 2. If it's green, it's either iron 2 or chromium 3. If it's brown, it is always iron 3. Okay? So you see iron 2 and iron 3. You add sodium hydroxide, green precipitate. You add sodium hydroxide, red precipitate. You add ammonia, green precipitate. You add ammonia, brown precipitate. Very easy. It's just green, brown. That's all. Chromium is almost the same, except chromium, it will be soluble in excess for sodium hydroxide, but iron 2 won't be soluble in excess. Okay? I'm not asking
Yes.
you to memorize. I'm asking you, do you understand what's going on? Memorize is
Yes.
later. Later, you slowly memorize. Now it's just understand what's going on. It's just how to test. Okay? Okay? So,
Mm-hmm.
copper, you will get blue precipitate insoluble in excess. If you use ammonia, you will also have blue precipitate, but if you put excess, it will dissolve to give a dark blue solution. Okay? And I'm not asking you to memorize now. I'm asking you to understand the concept of what's going on or not.
Yes.
Yes, okay. Now, finally, the last part is called flame test. Okay? This one you need a while to get used to. Okay. The
Oh,
one to
okay.
test the one to test the gases, the ones to test the gases, you understand now? Ammonia
Yes.
gas, use litmus paper. Carbon dioxide, lime water. Chlorine will bleach them litmus paper. Hydrogen is popped with a little splint. Oxygen is relights a glowing splint. And sulfur dioxide is same as sulfide using aqueous potassium manganate 7. Changes from blue to colorless. Okay?
Yeah.
Can I?
Uh-huh.
Okay. Now, the flame test is like this. You take a Bunsen burner, you must put it on blue flame or roaring fire. Then you dip your salt, whatever salt you're testing, you dip it in a chrome wire or you dip it in a burning on a splint and then you place it in the roaring flame and then you observe the color of the flame. If the flame is red, it is lithium. If it's yellow, it's sodium. If it's lilac, it is
Potassium.
potassium. If it's orange green, orange red, it is calcium. If it's light green, it's barium. If it's blue green, it is copper 2. Okay? So these are the colors of the colors of the things formed. Okay? Can?
Yes.
Got it?
Yes.
Okay. All right. So that's it. I'm going to show you how a sample question is asked. I'm going to send you one example, okay? So in your paper 6 question, they will give you the one that I just shared with you. Okay, they will give it to you on the last page. So you don't need to memorize like that. Hold on, ah. Okay, I send to you now. You just look at the question. Don't worry about. You just look at the question and think whether you're able to do it now. Yeah, just send.
Papa, you printing right?
Hey, you don't need to print it out now. Just do first.
Oh, okay.
Where you want? You don't need to print it out.
Oh, okay.
When you try and
The
do the question,
Hmm.
try and figure out the question, okay?
Okay.
It's really not that hard. You look at the question, then you go like, oh, che, like that only. It's just you need to remember hold the list eventually. No, no, no. Do you know what to do? 2 pages, ah. 2 pages, okay, Zihua?
Okay. Miss can scroll down a bit.
Done. Can we discuss?
Not yet. Almost.
Okay.
The first page done, Leo.
Yeah.
I said red flame, and then because
Okay.
of
Lithium chloride. Okay, so what's the color of the flame test? So if you look
red,
at here, they said red. Okay, so good. Okay, so red. And then,
yellow might cover yellow might hide the color of the test flame.
yeah. Okay, will disrupt, will make it unable to see the flame test color. Okay, can. Anything can. As long as you're logical. Okay,
This
so
one
lithium chloride. Okay, nitric acid followed by a few drops of what do you see?
white precipitate.
Yeah, you understand the concept now? Simple, right?
Yes, but
You must
hard and
memorize now.
simple at the same time.
It's simple, but a lot of things to remember. To the second portion, you add sodium hydroxide. What will you see?
No precipitate.
Nah, no changes, huh? Or no precipitate or no changes, correct.
Simple in the way that you don't need to think.
Okay, now this one, you look at it. If there is condensation, this one I've taught you before. If there's condensation and it changes anhydrous cobalt chloride from blue to pink, who is that? Who can do this change? Only water. This is to test the presence of water. If you're doing that, that means this is a hydrated salt. Do you remember what's a hydrated salt? That means salt with water vapor inside.
Yeah.
Okay, all right. Okay, look at the rest. So this is a hydrated. So this one tells me it's hydrated salt. Okay, you read this and then you compare. Are you done?
No.
Come. So, green precipitate forms and green precipitate remains in ammonia. So, who is that? So, you look at the list. For ammonia, green precipitate insoluble in excess. Green, green precipitate insoluble in excess. So, it could be chromium 3 or it could be iron 2 because it's the same results. Correct now? Hello.
Yes.
Okay.
Ammonia.
That's right. Identify the two possible cations, chromium 3 or iron 2.
Iron 2.
There. Okay.
Okay.
All right. This one is nitric acid and barium nitrate. Then got what? Precipitate.
White precipitate.
Who is it? Barium is test for
Barium. Barium is. Let me check my note. Chloride. Barium sulfate.
sulfate. So it's a sulfate. Okay. It should be a sulfate. And then to the third portion, add 3 centimeter cube of sodium carbonate. Test any gas given out. Lime water turns milky, so it has to be carbon dioxide, and this one has to be, oh, carbon dioxide. Okay, so I want you to figure this one out. I want you to figure this one out. Actually, there's one more page. I'm going to send it to you together with 2 other sets. You print out and then you try and do it yourself, can?
Okay.
Okay, there's another page here. I forgot to print out another page. Okay, so there's going to be 3 pages of this and then another 2 sets. So you do it at home. It's homework. You print it out and do again. Can?
Okay.
Okay. All right. I see you next week. Bye bye. Any
Bye bye.
questions?